The universe is filled with objects so large that our brains struggle to comprehend them. Entire galaxies, supermassive black holes, stars millions of times larger than Earth. But some of the most important objects in the cosmos are surprisingly easy to overlook. Nebulae, enormous clouds of gas and dust drifting through space. Some give birth to stars, some are created by dying stars, and others contain enough material to build thousands of solar systems. Today we're exploring every major type of nebula and uncovering the role they play in the life cycle of the universe. Before a star exists, there is usually a molecular cloud. These are some of the coldest objects in space. Temperatures can fall to hundreds of degrees below freezing. Despite their low temperatures, molecular clouds contain enormous amounts of hydrogen, helium, and dust. Some stretch across hundreds of light years. Inside these clouds, gravity slowly begins pulling material together. Over millions of years, this process creates dense regions that eventually collapse into newborn stars. Without molecular clouds, stars like our Sun would never have formed. In many ways, they are the starting point of nearly every stellar story. Some nebulae are famous because they glow. Dark nebulae are famous because they don't. These dense clouds block the light behind them, creating massive dark shapes in space. At first glance, they appear empty, but the opposite is true. Many dark nebulae contain enormous stellar nurseries hidden from view. One of the most famous examples is the Horsehead Nebula. Its dark silhouette has become one of astronomy's most recognizable images. What makes dark nebulae fascinating is that they often hide the very stars they are creating. As new stars begin to form, something interesting happens. The youngest and hottest stars release powerful ultraviolet radiation. This radiation strips electrons away from nearby hydrogen atoms. The result is an H2 region. These glowing regions can span hundreds of light years. Some contain thousands of newly formed stars. The famous Orion Nebula is part of a giant H2 region. When astronomers search for active star formation, these regions are often the first place they look. Emission nebulae are among the brightest objects in space. Unlike dark nebulae, these clouds produce their own visible light. Powerful radiation from nearby stars energizes the gas inside them. As the gas releases this energy, it begins to glow. Many appear red because hydrogen emits red light when excited. These nebulae are some of the universe's most beautiful structures. But they're also surprisingly violent environments filled with intense radiation and powerful stellar winds. Not every nebula glows on its own. Some simply borrow light from nearby stars. These are reflection nebulae. Tiny dust particles scatter blue wavelengths more efficiently than red ones. This gives many reflection nebulae their distinctive blue color. Without nearby stars, these clouds would be nearly invisible. They're essentially giant cosmic mirrors floating through space. Most nebulae sit relatively still. Bowshock nebulae form when stars move rapidly through space. As the star plows through surrounding gas, it creates a shock wave similar to the bow wave created by a ship moving through water. The result is a curved structure that appears to be pushed ahead of the star. These nebulae allow astronomers to track the movement of stars through the galaxy. They're essentially cosmic speed trails. Some stars create nebulae around themselves long before they die. These are known as circumstellar nebulae. Powerful stellar winds slowly push material away from the star. Over time, enormous shells of gas begin to form. Studying these nebulae helps astronomers understand how stars lose mass throughout their lifetimes. They're like snapshots of a star gradually changing over millions of years. Sometimes two stars share a much more complicated relationship. Symbiotic nebulae form in binary star systems where material moves between two stars. One star may steal gas from its companion. The interaction creates unusual clouds, jets, and structures. These systems often produce some of the strangest shapes observed in astronomy. They remind us that space is far more dynamic than it first appears. Not all nebulae are spherical. Some resemble giant cosmic butterflies. These are known as bipolar nebulae. Instead of expanding equally in every direction, material is expelled along two opposite lobes. The exact cause isn't always clear. Magnetic fields, companion stars, and rapid stellar rotation may all contribute. The Butterfly Nebula is one of the most famous examples. Its enormous wings stretch across light years of space. Eventually, stars similar to our Sun begin running out of fuel. Before they become planetary nebulae, they enter a brief transitional stage. This stage creates a protoplanetary nebula. These objects are extremely rare because the phase lasts only a few thousand years. On cosmic timescales, that's almost instantaneous. Many display spectacular jets and unusual structures that astronomers are still trying to understand. Despite the name, planetary nebulae have nothing to do with planets. They form when sun-like stars shed their outer layers near the end of their lives. The hot stellar core illuminates the expanding gas, creating beautiful rings and shells. Some of the most famous images in astronomy are planetary nebulae. The Ring Nebula, the Helix Nebula, the Cat's Eye Nebula. Wolf-Rayet stars are among the hottest and most massive stars known. They lose material at astonishing rates. The powerful winds generated by these stars carve enormous structures into surrounding space. The nebulae they create are often highly energetic and chaotic. Most Wolf-Rayet stars are living on borrowed time. Many will eventually explode as supernovae. When massive stars die, they don't fade quietly, they explode. For a short period, a supernova can outshine an entire galaxy. After the explosion, expanding debris races outward at millions of kilometers per hour. This debris forms a supernova remnant. The Crab Nebula is one of the most famous examples. These nebulae contain many of the heavy elements needed to build planets and life. Iron, calcium, oxygen. Even the atoms in your body were likely forged inside stars that exploded billions of years ago. Sometimes a supernova leaves behind something even stranger, a pulsar. These rapidly spinning neutron stars release powerful streams of charged particles. The particles collide with surrounding material, creating a pulsar wind nebula. The result is an incredibly energetic structure powered by one of the most extreme objects in the universe. Some pulsars rotate hundreds of times every second, yet despite their tiny size, they can influence regions spanning light years. Every star begins somewhere. Every star ends somewhere. And throughout that entire journey, nebulae are there, creating stars, shaping stars, and preserving the remains of stars long after they're gone. From cold molecular clouds to the glowing remnants of supernova explosions, nebulae tell the story of the universe itself. And perhaps the most incredible fact is this: the atoms that make up you, your planet, and everything you've ever known were once part of ancient nebulae drifting through space. In a very real sense, we are all made from cosmic clouds.